Not right now. I'm done with this one already. Similar shapes have the same shape, but they don't have to be the same size. And if they have the same shape, this is going to be a big word for you, but I'll just throw it out at you. They have to be proportional. Does anybody know what the word proportional means? Things are proportional. Like if somebody said that your head wasn't proportional to your body, what would that mean?
Different?
So Amy?
The same size, or like the, not the same size, but like.
Oh, it could be too big or too small. But what's it mean? To not be proportional means that it is, Lance? Yeah, different than what you'd expect. Not in the same,
Not exact.
not in the same measurement. Kate,
It has the same shape.
if it's not proportional, it wouldn't have the same shape.
Oh, is it?
Different, Charlie?
Not fit.
Yeah, kind of not fit. And I like to use what I call the balloon concept. The balloon theory. And that is this. If you take a balloon, let's say your balloon starts out looking like this. And this guy blows up the balloon. Okay, when you blow up the balloon, all of the sides grow at the same rate. Okay, these two shapes would be similar because when you blow up a balloon, all the sides get bigger at the same time. If you're blowing up a balloon, you don't have one side stay flat and the other side get really big. Okay, they blow up together. And that's the same thing. If you have, let's say you have a triangle. I don't want that triangle, try a different triangle. Let's say I have a triangle. Okay, here's one triangle, and then here's a separate triangle. Oh, sorry. I don't want that one. Okay, even though these two shapes are both called triangles, they are not similar. Jillian, are you actually listening to me? Because how can you be facing Allison, talking to her, and have any idea what I'm talking about? Anyway, I gotta find where would be the best maneuver to fix this problem. Back to this. Even though they're both triangles, they are not similar because if you think about the balloon thing, you know, if this was a balloon and I was blowing it up and it became this long, this side would also have to grow at the same rate. Okay, so how this one is really long and really narrow, it's much longer and much narrower than this one. For it to be similar to this, you would think it would look something like, you know, if it grew, it would end up looking a lot like maybe something like that. Okay. I want this one. Okay. Where it grew, where all the sides grew at the same rate. That has to be similar. All circles would have to be similar because you can't get a circle that doesn't look exactly when it grows up. A rectangle. If you had a rectangle that looked like this, how it's kind of long and skinny, for another rectangle to be similar to it, it would also have to be, if this side got twice as big, it would also have to get twice as big this way. So those two could be similar. But this rectangle here would not be similar to this rectangle here, even though they're both rectangles, because this one is a short, stubby one, this one is a long, narrow one. And they have to grow together. So you have to be careful with similar things. Are congruent things similar? Yes, they are. If things are equal, they're going to be similar no matter what.